Welcome to the Q&A session 13 from the playlist of JEE Advanced Part 2. The topic is the electric flux through the surfaces, and I have taken one question which was asked in the JEE Advanced examination in the year 2021. So this was a question which was asked in the JEE Advanced in the year 2021. And this question is based on this topic, that is electric flux through the surfaces. So the question here is an electric field vector given by this equation E is equal to 4x I cap minus in bracket y square plus 1 j cap Newton per coulomb passes through the box as shown in this figure. So this was the figure which was provided along with the question. So the flux through the ABCD is given as phi 1. And the flux which is passing through the surface BCGF. BCGF is BCGF and ABCD is ABCD, this upper surface. So the flux passing through ABCD is equal to phi 1 and the flux which is passing through BCGF is phi 1. So phi 1 minus phi 1 is equal to, so we have to find the difference of phi 1 and phi 2. So we know that the flux passing through a surface is given by EA cos theta, where theta is the angle made by the normal to the surface and the direction of electric field. So cos theta, so theta is the angle made by the normal to the surface and the direction of the electric field. E is the intensity of the electric field and A is the area of cross section. So let us first of all find the value of phi 1, that is the flux through ABCD. So here from this equation we can see that the electrical field has got two components. One component is directed along the positive x-axis and it is equal to 4x. So I can just write it here. That is the electric field intensity along the positive x-axis will be equal to 4x, whereas the electric field intensity here, this is minus y square plus 1 j cap, means that the electric field intensity along the minus y-axis is equal to y square pi plus 1. Minus j cap means minus j cap is the unit vector along the y-axis. So minus j cap is the unit vector along the minus y-axis. I cap is the unit vector along the positive x-axis, and if it is minus I cap, then it will be the unit vector along the minus x-axis. So in this case, the intensity of the electric field along the positive x-axis will be equal to 4x, and the intensity of the electric field along the negative y-axis is equal to y square plus 1. Now, we have to find the flux through ABCD, which is phi 1 in this case. So, phi 1 in this case will be equal to what? See, the flux will be because of these two components, that is because of the electric field along the x-axis and the electric field along the minus y-axis. Now, the angle made by the direction of the electric field along the positive x-axis and the normal to the surface. The normal to the surface ABCD will be like this. Okay, and the angle made by the direction of the electric field along the positive x-axis will be, that is in this case, the theta will be equal to 90 degree. So the flux due to the electric field which is directed along the x-axis will be equal to 0. Now, the intensity of the electrical field along the negative y-axis. Now, the negative y-axis, if this is the positive y-axis, then this will be the negative y-axis, like this. So, the intensity of the electrical field along the negative y-axis is equal to y square plus 1. So, this is the direction the direction of the electric field will be along the negative y-axis. So the angle made by the normal to the surface ABCD with the negative y-axis will again be equal to 90 degree. So the flux due to the electric field which is directed along the negative y-axis will also be equal to 0. So the flux through the surface ABCD will be equal to 0. That is, the flux due to the electrical field directed along the x-axis will be equal to 0, and the flux through this surface ABCD due to the electrical field which is directed along the negative y-axis will also be equal to 0. So phi 1 will be equal to 0. Now we have to find the flux through the surface BCGF. Now we know that here that the intensity of the electrical field is directed along the x-axis is given by 4x. Now here for the surface BCGF, the value of x will be equal to 3. See, this surface BCGF this line, this BCGF is the surface which is located at a distance of x is equal to 3. So the intensity of the electric field will be, that is, the intensity of the electric field through this surface BCGF will be equal to, I am just writing here as BCGF, this will be equal to 4 into x, that is 4 into 3, which is equal to 12. Now the flux due to this electric field will be given by this formula, that is EA cos theta. Now here the direction of the flux, the direction of the electric field which along the x-axis is parallel to the normal to the surface BCGF. That is, the normal to BCGF and the direction of the electric field along the x-axis are parallel to each other, or we can say that theta is equal to 0. So when theta is equal to 0, then flux will be equal to EA. So flux will be simply equal to E into A. Now E is equal to 12. A is what? A is the area of cross section. So here the area of cross section will be equal to, see, this length, that is FG. FG is equal to 2. This is 2. And FB, this is also equal to 2. So the area of cross section will be equal to 4. So the flux due to the electric field which is directed along the positive x-axis through the surface BCGF will be equal to 12 into 4. And this is the flux due to the electrical field which is directed along the x-axis. Now we have to find the electrical field, the electric flux through the surface BCGF due to this electrical field which is directed along the minus y-axis. Now the angle theta between the electric field which is directed along the minus y-axis and the normal to the surface will be equal to 90 degree. So in that case, the flux, because of this electric field which is directed along the minus y-axis, will be equal to 0. So the total flux, that is 511 passing through the surface BCGF will be equal to 48 and the unit of this will be equal to Newton meter square per coulomb. So the difference of that is 5 minus 511, this will be equal to 0 minus 48. So this will be equal to minus 48 Newton meter square per coulomb. So the answer is minus 48 Newton meter square per coulomb. That is the difference. That is the difference of 5 and 5. That is 5 minus 511 will be equal to minus 48 Newton meter square per coulomb. So thank you very much for joining this session. In the next session, I will be coming up with another different type of a question from the chapter of electric charges and fields. And so till then, have a nice day. Bye.